This is an introductory part of CH110, and in this video we'll look at measurements as well as temperature scales. Okay, so for measurements, let's say you have a liquid in a beaker. So for this liquid in a beaker, it's possible to find what? To find volume. Rather than volume, it's also possible to find the mass of the liquid. It's possible to also find the mass of the liquid. Now, to find the volume and the mass of the liquid, of course, we use different apparatus. So what are we getting from this? We are simply saying that chemists measure properties of substances using different instruments. So we should know some instruments that are used to measure certain properties of substances. For example, we can say instrument, then measured property. Property measured. Okay. So for an instrument, let's say if we talk about burette, rather than burette, let's say pipette. Apart from this one, even a graduated cylinder or volumetric flask. So for those, you find that what property do they measure? Use these to measure volume, of course. And some of the units we can say milliliters. Okay. Then what about if we have a beam balance or an electronic balance? So a beam balance or an electronic balance, of course, to be used to measure what? Its mass, right? Yes. And mass, we can use grams, kilograms, and so on. Then let's say we have a stopwatch. So for a stopwatch, it can be used to measure what? Of course, it's time. Yes. Time we can use seconds. Then let's say we have a thermometer. So for a thermometer, automatically it's temperature. We can use degrees Celsius, Kelvins, and so on. So these are simply some of the instruments and the measured properties. Of course, there are more instruments and properties you can measure. Okay, so apart from this, let's also talk about the SI units. So SI units, we can simply say, so this abbreviation simply stands for International System of Units or System International Day Units. So this one actually forms what we call the metric system of units. These are the 7 base quantities. So makes up the 7 base quantities. So we should know these 7 base quantities. So from these 7 base quantities, we form other quantities. So base quantities are also called what? Fundamental quantities, right? Fundamental quantities. So we should know these 7 base quantities or fundamental quantities. Then from these, we can form other quantities, the ones we call the derived quantities. Okay. Then, so what are these quantities? So I'll say quantity there, name of unit. So name of unit. Then this side I'll say the symbol used. Okay, so we have that. Let's start. So the first quantity which we'll start with is length. So length is under the 7 basic quantities. Okay, so length, the name of the unit, of course, we use meter. Length is measured in meters, so it's meter. Symbol is just small letter m, like that. Then rather than length, we have mass. So for mass, of course, the SI unit, it's kilogram, and we use K, G. So it's small letter K and G like that. Apart from mass, we also have time. So for time, we use second. It's small letter S. That's the symbol that side. So apart from time, we also have electric current. Electric current. So for this one, we use amps or simply ampere. And we use a capital letter A like that. Rather than electric current, we also have even temperature. Okay, so temperature. Then for temperature, the SI unit, so using Kelvin. And it's capital letter K, so use capital letter K. Rather than temperature, we have amount of substance, so amount of substance. Amount of substance. So for amount of substance, this is actually a mole. So we use mole, then the symbol is simply MOL like that. Okay, and the last one we can say luminous intensity. Luminous intensity or simply light intensity. So for luminous intensity, we use what we are calling candela. So for candela, it's C and D like that. So these are the 7 base quantities that you should take note of. These are the 7 base quantities. You can count 1, 2, 3, 4, 5, 6, 7 of them, as well as their SI units. So from these 7 base quantities, we form now what we call the derived quantities. So for the derived quantities, I'll just give you some examples as well as their units. Okay. So from those we form what we are calling derived quantities. So from the base quantities we form derived quantities. So these are simply quantities that are formed from those base quantities. And some of them, so some examples, can talk about area. So area, we know that area, for the units for area we use what? It's meter squared, right? Meaning that area is formed from what? So meter, that's length. So we can say area is formed from what? Length. By multiplying length by itself we form area. Rather than area, we can even talk about even volume. That's a derived quantity. Volume, we know that we use meter cubed like that. That's the unit. Then this is meter, meaning it's also formed from what? Length, just being multiplied 3 times by itself. Rather than that, we also have even density. All these are derived quantities. So density, SI unit, we know it's what? Kg per cubic meter. Kg per cubic meter, we know this is formed from what? It's mass and what? Meter cubed. So mass and length. Those are the base quantities that make up density. Rather than density, even what? We can also talk about units like force. Yes. We know that for force, what do we use? It's we use newtons, right? Yes. And for newtons, from the formula for F is equals to ma, like that. F equals to ma. Know that this is mass. Then in acceleration, so what are the units? Mass, it's kg, right? Then acceleration, it's meter per second squared like that. Then you should note that this one can also be written as what? Kg meter second -2 like that. Same applies to this one. You can also write that it's what? Kg meter to the power -3. If we don't use per, this power becomes negative there. Those of indices or exponents. Okay, so we can see that this force equals to ma is formed from what? This is mass, that's length, that's time. So mass, length, and time. Okay, apart from that, we can also talk about things like pressure. So pressure, so we know that pressure, the formula is simply force over area. Then under force, what do we have? We have that unit, which is kg meter second. Then area, it's meter squared. So this one can be simplified further. We end up with what? Kg m negative 1 s negative 2, like that. So as you can see, kg, that's mass, then meter, that's length, time is second. Yeah. So these are simply some of the examples of derived quantities and their derived units. You can see that all these are being formed from those 7 base quantities. Okay, that's it. Then rather than that, we should also talk about prefixes. So even in chemistry, we're using prefixes. Okay, so for prefixes, we say prefixes, these are simply multiples or sub-multiples of units. So they make it easier to write very small numbers or very large numbers. So make sure you memorize some of these prefixes using this mnemonic. So that great morning, King Henry died unexpectedly, drinking chocolate milk, missing nature's picture, including this one, femto, 10 to the power negative 15. Okay, so make sure you go through the prefixes, you memorize them. So this mnemonic simply caters from 10 to the power 12 to 10 to the power negative 12, like that. But you can even go up to 10 to the power negative 24, but these ones are the ones which are commonly used. 10 to the power 12, 10 to the power negative 12, including this one, 10 to the power negative 15. Okay, so you should make sure you go through the prefixes, memorize them. So even in chemistry, we're using prefixes. Okay, then from there, let's talk about the units of volume. Units of volume. Okay, so there are a lot of units used to measure volume, so we should know the unit conversions for volume. We know that for SI units under volume, SI units, of course for SI units we're using cubic meter, like that. That's the SI unit for volume. So apart from the SI units, we also have other units, so we should know these other units as well. Okay, so other units, we have milliliters, cubic centimeters, also have cubic decimeters. Apart from cubic decimeters, also have liters. Apart from, okay, let's concentrate on this. Okay, milliliters, cubic centimeters, cubic decimeters, and liters, including cubic meters. Now we should know some conversions. Okay, so we should take note of this. So should take note of this. So you should know that 1 liter actually is equal to what? 1 cubic decimeters. These are some of the what? Conversion factors. Then this is actually also equal to 1000 milliliters. Apart from being equal to 1000 milliliters, this is also equal to 1000 cubic centimeters, like that. So 1 liter is equal to 1 cubic decimeter. It's equal to 1000 milliliters. It's also equal to 1000 cubic centimeters. So this simply means that actually 1 milliliter is the same as what? It's the same as 1 cubic centimeters. Yes, like that. Then we should also know that 1 cubic meter is equal to what? 1000 liters. 1 cubic meter is 1000 liters. So these are some of the units of volume and their conversions. So make sure you take note of these. We'll be using them even when you start looking at gases converting volumes. So make sure you take note of these, the conversions especially. Okay, so apart from this, we can proceed to something else. So let's proceed to something else. Let's talk about temperature scales. Temperature scales. Okay, so for temperature scales, we have 3 temperature scales which are commonly used. So, on the first one, we have the degrees Celsius. Degrees Celsius. Apart from degrees Celsius, we also have the Kelvin. The Kelvin. Okay. Apart from the Kelvin, we also have the degrees Fahrenheit. So we have the degrees Fahrenheit. Okay, degrees Fahrenheit, like that. So these are the temperature scales which you should know. Okay, then there are some common comparisons which we should know. For example, so I can give you some examples of common values for temperature. For example, if we talk about the melting point of water in degrees Celsius, we know it's what? 0 degrees Celsius. If we talk about the room temperature, that's about 25 degrees Celsius. If we talk about the normal body temperature, which is 30 degrees Celsius. And the boiling point of water, which is about 100 degrees Celsius. Okay, so let's try to compare scales using those. So if I see a scale there, let's say water boiling point. Water boiling point. Boiling point. So boiling point of water. Apart from boiling point of water, let's also talk about room temperature. Okay, so these are just examples I'm giving you. Then normal body temperature. And also, lastly, let's talk about the boiling point of water. Water boiling point. Boiling point. Okay. So let's compare these 3 types of scales. And the first one, let's start with degree Fahrenheit. So in degree Fahrenheit, the freezing point of water, actually I've used the water boiling. I was supposed to say water freezing there. Okay, so it's freezing at that point. So this is freezing point of water, boiling point of water there. Take note. Okay, so the freezing point of water is actually 32 degrees Fahrenheit. That's the freezing point of water, 32 degrees Fahrenheit. Then in degrees Celsius, this is equal to what? This is 0 degrees Celsius, like that. Okay. Then the last one in Kelvin. In Kelvin, let's say K there. So in Kelvin, it's actually 273 Kelvin, like that. So this is the freezing point of water, comparing the 3 scales. Then for the room temperature, it's about actually 77 degrees Fahrenheit. Then there we know it's 25 degrees Celsius, right? Then there it's 298 Kelvin. 298 Kelvin. Then the board temperature, normal board temperature, it's about 98.6 degrees Fahrenheit. Then it's about 37 degrees Celsius. Then we have about 310 Kelvin. Then the boiling point of water, it's actually about 212 degrees Fahrenheit. Then for degrees Celsius, it's actually 100. Then 373 for Kelvin. So these are some of the conversions. So now what's important is for us to know how to convert from Fahrenheit to Celsius, degrees Celsius, and to Kelvin. So we should know the temperature conversions calculations now. So that is what is important. We should know that. Okay, so let's actually talk about the calculations under temperature. So calculations or simply conversions. Okay, so under calculations, we should know the formulas that are used when converting temperature from one scale to the other. So let's say we are converting from, so number one, let's say we are converting from degree Fahrenheit to degree Celsius. Yes, let's say we are converting from degree Fahrenheit to degree Celsius. So this is the formula you should know. Degree Fahrenheit is actually equal to, so you get the temperature in the degree Celsius minus H2 degree Fahrenheit. Then you multiply by 5 degrees Celsius over 9 degrees Fahrenheit. So this is the formula that we use to convert from degree Fahrenheit to degree Celsius. So its temperature in degree Celsius equals to that. Yes, that's the formula. So that's the first formula you should take note of. Then the second one, what if you are converting from degree Celsius to degrees Fahrenheit? Degree Celsius to degrees Fahrenheit. Okay. So to convert from degrees Celsius to degrees Fahrenheit, we use this formula. So you say degrees Fahrenheit is equals to, so its temperature in degrees Celsius multiplied by 9 degrees Fahrenheit over 5 degrees Celsius, then plus 32 degrees Fahrenheit. So this is the formula to use. So just take note of that. Temperature conversion from degrees Celsius to degree Fahrenheit. Degree Fahrenheit equals to degree Celsius multiplied by 9 degree Fahrenheit over 5 degrees Celsius plus 32 degrees Fahrenheit. So that's the formula. Take note. Okay, then the last formula, of course, for this one, if you are simply converting from Kelvin to degree Celsius or Celsius to Kelvin, that's direct, right? Simply temperature in what? Kelvin equals to temperature in degrees Celsius plus 273.15. So this is the formula we use, such that if you want temperature in degrees Celsius, you simply make this subject to the formula. We can say temperature in degrees Celsius equals to temperature in Kelvin. So it's temperature in Kelvin minus 273.15. Okay, so these are the formulas you should take note of for temperature calculations. Take note of these formulas. So from here we should solve some questions for under temperature conversions. Should solve some questions. Okay, just get the questions to solve. Okay, so these are some of the questions we'll solve. So we have to convert a 327.5 degrees Celsius to degrees Fahrenheit. Okay, so that's the first question. Just get rid of this. So I'll say solutions this side, solutions. So question 1. Okay, so question 1a. So let's check. We are converting 327, that's 0.5 degrees Celsius to degrees Fahrenheit. So here we use the formula for converting from degrees Celsius to degrees Fahrenheit. And we know that the formula is what? It's degrees Fahrenheit equals to temperature in degrees Celsius multiplied by 9 degree Fahrenheit over 5 degrees Celsius plus 32 degrees Fahrenheit. So here we simply substitute. On degrees Celsius, it's 327.5 degrees Celsius multiplied by 9 degrees Fahrenheit over 5 degrees Celsius plus 32 degrees Fahrenheit. As you can see, this degree Celsius and that degree Celsius will cancel. So just multiply first, then you add. So you deal with the multiplication part first, then you add 32. Okay, so let's multiply there. 3. So we have 327.5 multiplied by 9. The answer should be divided by 5 plus 32. So I'm getting 621.5. You can confirm that by using calculator as well. 621.5. Then the answer should be what? It's degree Fahrenheit. So we have converted just like that. Okay, so that's it for A. Then B, let's check. We are converting 172.9 degree Fahrenheit to degrees Celsius. Okay, so we are converting from degrees Fahrenheit to degrees Celsius. So just write the formula. So degrees Celsius should be equal to what? It's temperature in degrees Fahrenheit minus 32 degrees Celsius, then multiply by what? 5 degrees Celsius over 9 degrees Fahrenheit. So temperature in degrees Celsius will be equals to, so let's just substitute there. We have, it's 172.9, that's what we have, degrees Fahrenheit, minus 32 degrees Celsius, then this should be multiplied by what? 5 degrees Celsius over 9 degrees Fahrenheit. So temperature in degrees Celsius will be equals to, okay, so let me just punch everything there. So I don't have enough space, so I'll just say 172.9, then minus 32. Okay, so I'm getting 140.9. The answer multiplied by 5. Final answer divided by 9. So I'm getting 78.3. 78.3. You can confirm that. 78.3. It's what? Degrees Celsius. Let me just write again the 172.9 minus 32. The answer, okay, then multiply by 5, so it's 78.3. Okay, so that's it, the answer for that one. Can move on to C. So for C, we are converting 77 Kelvin to degrees Celsius. Okay, so for that one, it's actually 77 Kelvin to degrees Celsius. And we know that the formula is what? So we say temperature in Kelvin should be what? Temperature in degrees Celsius plus 273.15. Okay. Then here we are converting this to degrees Celsius. So temperature in Kelvin there. We can even make temperature in degrees Celsius subject to the formula equals to. So it's temperature in Kelvin minus 273.15. So this will be equal to temperature in Kelvin, which is 77 minus 273.15. So this will give us what? If I say 77, so that's 77 minus 273.15. We're getting negative 196.115, negative 196.15, and it's in what degree? Degrees Celsius. Okay, so that's how you go about it. Then for D, helium. So helium has the lowest boiling point of all the elements at, so that's negative 452 degrees Fahrenheit. Convert this temperature to degrees Celsius. Okay, so it's actually the same thing we have been doing. Okay, so convert this temperature to degrees Celsius. So use the formula for what? Degrees Celsius. So in some cases you can be given the temperature, let's say like this same one. It has been given in degrees Fahrenheit. Then we might be required to convert it to to Kelvin. Yes, we might be required to convert it to Kelvin. So we know that we don't have a direct conversion from Fahrenheit to Kelvin. So what do you do? First convert it to degrees Celsius, then from degrees Celsius to Kelvin. Okay, so we'll do the same for this same one. Let's first convert it to degrees Celsius. So we know that temperature in degrees Celsius should be equal to what? It's temperature in degrees Fahrenheit minus 32 degrees Celsius multiplied by 5 degrees Fahrenheit over 9. 5 degrees Celsius over 9 degrees Fahrenheit. So this is equal to, we have negative 452 degrees Fahrenheit minus 32 degrees Fahrenheit. This multiplied by 5 degrees Celsius over 9 degrees Fahrenheit. So we have negative 452 minus 32, answer multiplied by 5 divided by 9. So should be solving along so that you are confirming. So this is actually negative 268.9 degrees Celsius. Yes. Then this one now can be converted to Kelvin. So we can say temperature in degrees Celsius will be equal to what? Actually, let me just say temperature in Kelvin should be equal to temperature in degrees Celsius plus 273.15. So there, I'll simply say negative 268.9 plus 273.15. Okay. So I have negative, that's 268.9 plus 273.15. So I'm getting 4.25 Kelvin. So it's possible to give you in degrees Fahrenheit, then you are required to find the temperature in Kelvin. It's not always that you use one formula. So we have used this formula and that formula. Okay, so for that, such cases where you don't have the formula for direct conversion, meaning you use one formula then the other. Hope you're getting the concept. Let's solve the last question, E. Okay, so for this one, mercury, the only liquid metal at room temperature, melts at, so it melts at what? Negative 38.9 degrees Celsius. Convert its melting point to Kelvin. So this is from degrees Celsius to Kelvin. We know we have a direct conversion for that. So simply say temperature in Kelvin should be equal to what? Temperature in degrees Celsius plus 273.15. So this will be equal to temperature in degrees Celsius, that's negative 38.9 degrees Celsius plus 273.15. So simply punch that on a calculator. So I have negative 38.9 plus 273.15. I'm getting 234.25. 234.25 Kelvin. That's it. Okay. So I hope you have understood for this video. That's it.